Alright, this is the two-dimensional figure test review coming up in a couple days. Um, Here we go, let's get started. First of all, number one, this figure is a triangle, so we want to find the area of the triangle. So the area of a triangle is equal to base times height divided by 2. All we have to do is plug in our numbers here. Base is 27, height is 3, we divide that by 2. You have to plug that into the calculator, 27 times 3 divided by 2. You end up with 40.5. Awesome, and that's it for number one. Number two, the shape is a parallelogram. The area of a parallelogram is equal to base times height. Plug in our numbers. The base is 19, the height is 15. Multiply 19 times 15, we end up with 285. We have this extra number 20 right here. It is extra. It is just there to throw you off. Okay? Number three. Number three is also a triangle, just like number one. So the area is equal to base times height divided by 2. Base is 18. Height is 9. Divide that by 2. 18 times 9 divided by 2. Plug that in the calculator. You end up with 81. We have our three answers for the first three questions. Awesome. Number four. Number four is a trapezoid. A trapezoid's equation for area is 1/2 base 1 plus base 2. Multiply all that by your height. In this example, we have 1/2 base 1 would be 9, base 2 is 13, and our height is 7. First, we can say 9 plus 13, we end up with 22. Multiply that by 7, and by 1/2, you end up with 77 in the calculator. Number 5. This shape is a parallelogram. Area of a parallelogram is base times height divided by 2. No, it's not. It's just base times height, excuse me. Okay, so the base in this one is 61. The height is 55. 55. Multiply these together, 61 times 55, and we end up with 3,355. Quite a nice number. Again, just like before on number 2, this extra number 40 is completely extra. It is not necessary to find the area. Awesome. Number 6, we know that this is a kite. On a kite, one diagonal bisects the other, meaning if this section is 8, this one down here is 8. We also know that the area is going to be the exact same equation as a rhombus. So we get area is equal to 1/2 diagonal 1 times diagonal 2. 1/2 diagonal 1. Let's call this one diagonal 1. 8 plus 8 is 16. 7 plus 21 is 28 for diagonal 2. Multiply these three numbers together. 1/2 times 16 times 28, and we end up with 224. Okay, let's move on to the next problem. Number 7. Number 7 is also a trapezoid, just like number 4. A trapezoid's equation for area is 1/2 base 1 plus base 2 multiplied by the height. 1/2 base 1 we're going to get as 16. Base 2 is 22. Multiplied by the height, we know the height. The height is 8. Okay, we can add these two numbers together. 16 plus 22. 16 plus 22 is 38. Okay, we can say 38 times 8. Multiply that by 1/2. And you end up with 152 in the calculator. Okay, number 8 is also a kite, just like number 6. And again, one diagonal bisects the other. So if this one up here is 3, this down here, also 3. Multiply these together. In your equation, area is equal to 1/2 diagonal 1 times diagonal 2. 1/2 diagonal 1 is 3 plus 3 is 6. 5 plus 11 is 16. 16 times 6 times 1/2, you end up with 48. Okay, those are for the basic problems, numbers 1 through 8. To move into slightly more difficult questions, we got number 9. Number 9 is asking which of the following below has the greatest perimeter. In order to find if A, B, or C has the biggest perimeter, we need to find the perimeter for all three shapes. Okay, the perimeter for A. How do you find perimeter? Perimeter in general is just add up the outsides of the figure. So for A is a trapezoid. To add them up, we're just going to say 20 plus 10 plus 15 plus 12. Add up all those together, we end up with 57. B, this is a pentagon, a five-sided figure. We know that on this shape we have a rectangle right here, where these are congruent to each other. It's what the little hash marks mean. If this side is 28, this one on the left is also 28. Similarly, up top, if this one is 8, this one is 8. Add up all the sides. 28 plus 28 plus 12 plus 8 plus 8. We end up with 28 plus 28 plus 12 plus 8 plus 8 is 84. And that's B. We already know, just from this, if the perimeter for A is 57, and the perimeter for B is 84, we know B is bigger than A, so we can already cross off A from our answers. For C, C is probably the most difficult figure to find the area for, or the perimeter for, because it's not giving us the sides of the shape. The shape is a square. All we're given is that this is a square, and we know the diagonal. We also know that this is a 45-90 triangle, and if we remember, 45-90, we know 45 corresponds with x, 90 corresponds with x, square root of 2. We know across from 90 degrees is 35, meaning that x square root of 2 is equal to 35, right here. Okay, we want to find x by itself to get across from 45. To do that, we want to get rid of this square root of 2. Well, it's being multiplied by x, so we want to divide by square root of 2. If we divide 35 divided by square root of 35 divided by square root of 2, we end up with 24.7, meaning this side is 24.7, and this side is 24.7. To find the perimeter, we just add up all the sides, all four of them, so 24.7 times 4, and we end up with 98.8. This is indeed larger than 84 and 57, so we know figure C has the greatest perimeter. Number 10 is using the exact same figures, but this question, this time it's asking us for the area. Which one is the biggest area? Okay, so let's start with part A. Figure A is a trapezoid, just like what we said before. In order to find the area of a trapezoid, we say it's 1/2 base 1 plus base 2 multiplied by the height. We do have all the information. Base 1 is going to be 15. Base 2 is 20. And the height is 10. 20 plus 15 is 35. 35 times 10 times 1/2 gives us 175. The next shape. This shape is again a pentagon, but we don't know how to find the area of just a pentagon like this, so we're going to have to split it up into two shapes, or many shapes that we know how to find the area for. We know if we draw this line right here, already drawn for us in the dotted line, it is a rectangle and a triangle up top. We do know how to find the area of a rectangle, and we know how to find the area of a triangle. All we have to do is find them separately and then add them together. So first of all, let's find the area for the rectangle. The area of the rectangle is rectangle base times height. The base is 12, the height is 28. 12 times 28 is 336. Next shape, the triangle up top. Let's do it up here. Triangle. In order to find the area of a triangle, it's base times height divided by 2. We already know the base because if this is 12, this part has to be 12. So we can plug that in. 12. We don't currently know the height. The height is this right here. So we're going to have to find that, and then we can divide that by 2. In order to find this, we know that the base down here is 12. We can split that in half. 6 and 6. This is a right triangle. And we could do Pythagorean theorem for a right triangle. So we can say 6 squared plus our unknown side, our other leg, x squared is equal to 8 squared. 6 squared is 36, plus x squared is equal to 8 squared is 64. We can subtract 36 from both sides. X squared is equal to 64 minus 36 is 28. To get rid of the squared, we take the square root, so x is equal to square root of 28. And the square root of 28, put that in the calculator, we end up with 5.29, which would round to 5.3. And this is our height. Let's plug that in, 5.3. Multiply these together, 12 times 5.3, and then divide that by 2. You end up with 31.8. For the total area, for this shape, we're going to add the rectangle, which is 336, plus the triangle, which is 31.8, and you end up with 336 plus 31.8, 367.8. So, given this, we know that it's going to be larger than this 175, so again, just like problem 9, we can mark out figure A. Figure C. In order to find figure C, we remember from the last time, from number 9, this side was 24.7. Again, we said it was 35 divided by the square root of 2, which in the calculator gives us 24.7. The side is also 24.7. It's a square. Area of a square is base times height. The base is 24.7. The height is 24.7. Multiply those together. You end up with 610.09, which rounds to 0.1. We can see that 610.1 is bigger than 367.8, and it's bigger than 175, meaning C is the greatest area. Next question, number 11, says to find the area of the rhombus. Area of a rhombus is 1/2 diagonal 1 times diagonal 2. Diagonal 1, let's call this one up and down diagonal 1. 12 plus 12 is 24. Diagonal 2 of 5 plus 5 is 10. 1/2 times 24 times 10 gives us 120. Next question, it should be number 12, but it's actually number 16. It says find the length of the regular hexagon with side length of 8. Okay, we know this is 8. On a regular polygon means that all the sides are congruent to each other, meaning they're all 6 sides 8. And we know the area of a regular polygon is 1/2 little a times big P. Little a stands for apothem. P stands for perimeter. Okay, we can first find perimeter. Perimeter is just add up all the sides. Well, if all of them are 8, we can say 8 times 6 sides. 8 times 6 is 48. The hard question is finding the apothem. Remember, the apothem goes from the center to the middle of one side. We can also draw the radius to give us a little triangle. On a hexagon, the triangle has angle measures of 90, 30, and 60. So we have our own little 30, 60, 90 triangle. We can remember this whole side is 8. We split it in half, we get 4 and 4. So now we have a 30, 60, 90 triangle. Where across from the 30-degree angle was our x. This is x squared of 3. This is 2x. Across from 30 degrees is 4. So across from 60, this is our x. Plug in our x. 4 square root of 3. And 2 times 4, which is 8. Across from 90, 8. Across from 60, 4 square root of 3. That's our apothem. This 8 for the radius isn't necessary to find area, but it's fun to do anyways. So we get 1/2 times 4 square root of 3 times 48. If we're multiplying with square roots, we say outside times outside and inside times inside. There is no other square root, so we're going to leave square root of 3 alone. We're going to multiply 1/2 times 4 times 48. 1/2 times 4 times 48. We end up with 96. So we get 96 square root of 3, and that is our total answer. Next question, number 13. Again, it's a rhombus. Area of a rhombus is 1/2 diagonal 1 times diagonal 2. Diagonal 1, 9 plus 9 is 18. Diagonal 2, 7 plus 7 is 14. 1/2 times 18 times 14, we end up with 126. Next question. Number 14, given the regular polygon, find the measure of each numbered angle. Since this is a regular polygon, that means all 4 sides are congruent and all the angles are congruent. If they're all the same, they're all going to be 90 degrees. So this shape is going to be a square. If this is a 90-degree angle, the diagonal on a square bisects opposite angles, meaning both of these angles are the same. So we can just say 90 divided by 2, we get 45 degrees. Similarly, on the other side, 1 would be 45 degrees. Measure of angle 1. The measure of angle 2, well, if this is 45, this is 90, so 2 would have to be 45. All 3 add up to 180. And the measure of angle 3, similarly, just like for angle 2, angle 3 would also be 45. Number 15. This is all about remembering and memorizing the angles on the insides of these regular polygons. Okay, on a triangle, how would we do this? Well, if this is a regular triangle, it's an equilateral triangle. Remember, on an equilateral triangle, all 3 angles are 60 degrees. If this is 60 degrees and we're cutting it in half, we can find the measure of angle 2 being 60 divided by 2, which is 30. Angle 1 would be 30 plus 90. This would have to be 60. 30, 60, 90 triangle. On a square, we just did this. We said measure of angle 1 is equal to 45, and measure of angle 2 is also 45. Remember, we said on a hexagon a couple questions ago, said the measure of angle 1 would be 30, and the measure of angle 2 would be 60. Number 17. If the perimeter of a square is 32 feet, we want to find the area of the square. Okay, well, let's first draw a square. Yeah, this square is not perfect, but that's okay. If the perimeter is 32, how do we find the area? Well, first we need to find what each side was going to be. On a square, all 4 sides are the same, so we're just going to take this and divide it by 4. We end up with 8. So all 4 sides have a length of 8. Find an area of a square. Area is equal to base times height divided by 2, not divided by 2, just base times height. If we plug numbers in, 8 would be the base, and 8 would be the height. 8 times 8 is 64. Next question, number 18. It says find the area of an equilateral triangle with side 8. Equilateral triangle. First, let's draw this triangle. If all the three sides are 8, because it's equilateral, we can say that the area is equal to 1/2 base times height, or base times height divided by 2. Okay, so base is 8, base. The height is going to be this right here. How would we find that? Well, we know if the base is 8, we can split it in half for each side. This is 4, this is 4. So we can use Pythagorean theorems that 4 squared plus x squared, our other leg, is equal to 8 squared. 4 squared is 16, plus x squared is equal to 8 squared, which is 64. Subtract 16 from both sides. 64 minus 16, we end up with 48. Take the square root to get rid of the squared. Okay, the square root of 48, if you put that in the calculator, square root of 48 is 6.9, and that would be our height, 6.9. So plug that in, 6.9. If you were to multiply these three numbers together, 1/2 times 8 times 6.9, we end up with 27.6. And that's our area. Next question, number 19. This is find the area of a pentagon if the apothem is 19 and each side is 28. Let's go ahead and draw this. Pentagon has 5 sides. It says the apothem from the center to the center of one side is 19. And each side is 28. Okay, it's going to be a regular pentagon, all 5 sides being equal to each other. So to find the area of a regular polygon, say area is equal to 1/2 A times P. A is apothem, which we know to be 19, it's given to us. And perimeter, to find perimeter, add up all the sides. Well, all 5 sides are all 28, so 28 times 5. 28 times 5 gives us 140. So multiply by the perimeter of 140. 1/2 times 19 times 140. 1,330. Next question, number 20. It says the figures are similar. We're going to find the ratio of the perimeters, the ratio of the areas, and it tells us we want to go from first figure, this one, to the second figure. So first of all, I'm only given one side from each figure. So what I can say is the first figure, 12, to the second figure, 16. And this would be our ratio of our sides. But can we reduce this? Yes, we can. They can each be divided by 4. So 12 divided by 4 is 3. 16 divided by 4 is 4. So we get a ratio of 3/4. And this is the ratio of our sides. If we remember, the ratio of sides is always the same as the ratio of the perimeters. So if the ratio of sides is 3/4, the ratio of our perimeters is also 3/4. To get the ratio of the areas, we take the ratio of the perimeters, or the ratio of the sides, and we square each one. So 3 squared gives us 9. 4 squared gives us 16. So the ratio of the areas would be 9:16. The next question, number 21, is very similar to number 20, just like what we just did. So first, find the ratio of the sides. We get 21:14. We can reduce these. They can both be divided by 7. 21 divided by 7 is 3. 14 divided by 7 is 2. This is a ratio of our sides. And it's going to be the same as the ratio of the perimeters, so also 3:2. To find the ratio of the areas, you square each one. 3 squared is 9. 2 squared is 4. Next question, number 22. We're given some circles. It says find the circumference. The circumference the equation is either going to be 2 pi r or pi times diameter. So circumference. We're given radius on this one, so let's go ahead and use 2 pi r. Let's plug in our radius. So 2 times pi times 18. 2 times 18 is 36. We get 36 pi. This answer, 36 pi, is what we call in terms of pi. Okay, so we're going to leave it just like that. But the question also says find the answer in terms of pi, which we just did, and to the nearest tenth. So how do we find it to the nearest tenth? To the nearest tenth, we're going to plug this into the calculator. So we're going to say 36 times pi. We end up with 36 times pi is 113.09, which rounds to 0.1 if we're rounding to the tenths place. So we have two answers here, 36 pi and 113.1. Next question, number 23, says we want to find the circumference again in terms of pi and nearest tenth, but this time we're given the diameter, so let's use the second equation instead. So we say circumference is equal to pi times diameter. This time we know the diameter is 25.9, so pi times 25.9. If we leave it in terms of pi, we're going to just leave it just like this, 25.9 pi. If we're going to multiply this out and round to the nearest tenth, we plug this in the calculator. 25.9 pi gives us 81.36, which rounds to 4. 81.4. Next question. It says find the area of a circle in terms of pi and to the nearest tenth. So this is the exact same thing as number 22 and 23, except this time we're looking for area. The area of a circle is pi r squared. So we can plug in radius, because we already know it, pi times 14.7 squared. If you plug 14.7 squared in the calculator, you end up with 216.09 or 0.1 pi. This is in terms of pi. Plug it into the calculator, 216.1 pi, and we end up with 678.89 or 0.9. And this is rounded to the tenths. Next one, number 25. It says find the area of a circle in terms of pi and to the nearest tenth. So we're going to find the area, again, is pi r squared. Okay, pi r squared. We're given the diameter though. Diameter is 4.1. To find the radius, you divide it by 2. So 4.1 divided by 2 is 2.05. So we can plug this in. Pi times radius, 2.05 squared. 2.05 squared gives us 4.2. So we get 4.2 pi, and this is in terms of pi. If we're plugging it into the calculator to get to the nearest tenth, we say 4.2 pi, and it gives us 13.2, and that's rounded to the nearest tenth. Next question, number 26. Number 26 says find the area of the shaded portion of the figure. The figure is made of a square and a circle. So to find just the shaded region, first we want to find the area of the square, then find the area of the circle, and subtract the two. So let's find the square first. Square. area of a square is just base times height. Base is 46. Height is also 46. 46 times 46 gives us 2,116. And that would be the area of the square. We could also find the area of the circle. Area of a circle is pi times radius squared. We know the radius is 23, so plug it in. 23 squared gives us 529. And we leave pi. This is in terms of pi. But we want to round this answer to the nearest hundredths. Okay, and we can't subtract 2,116 minus 529 pi, so we're going to go ahead and plug this into the calculator. And if you do, you end up with 1,661.9. Except we're going to round to hundredths in this case. So we're going to actually go to 0.90. Okay, and subtract them. 1,661.90. If you plug that into the calculator, you end up with 454.1. And this is our area of our shaded region. Next question, number 27. It's also find the area of the shaded region. A little hard to tell, but this 23 on the inside is the length of the base of this triangle, so I'm going to just go ahead and put that there. Okay, so let's find the triangle first. Area of a triangle is base times height divided by 2. The base of the triangle we said was 23. The height is 19. And then divide that by 2. 23 times 19 divided by 2 is 218.5. Again, we're going to round to the nearest hundredth, except there is no hundredths place, so we can go ahead and put a 0 here. On the circle, to find the area of a circle, we say area is equal to pi r squared. That's kind of wonky pi. Okay, so we get pi. Radius in this case is 5 squared. 5 squared is 25. We get 25 pi. Again, since we're rounding to the hundredths place, we're going to go ahead and put this in the calculator. So 25 times pi gives us 78.54 if we round. So we're going to subtract them now. 78.54. So 218.50 minus 78.54 gives us 139.96. Next question, number 28. There is a lot of words in this. We need to make sure we read very carefully. Okay, number 28 says, by using a drawing Alexis saw in a museum, an artist was able to make a larger production. So she's going to use a drawing to make a larger production. She's going to make it bigger. The larger painting was similar to the smaller painting, and the area of the larger one is 16 times the area of the smaller one. So just with that, I already know I can come up with a ratio of our areas, and it's going to be 16 times bigger, so it's going to be 1 to 16 ratio of our areas. We want to find the scale factor and the ratio of perimeters between the dimensions. Okay, so to do that, we're going to work backwards from what we did before. To go from ratio of areas down to the ratio of the perimeters this time, we have to take the square root. So the square root of 1 still 1. Square root of 16 is, square root of 16, I'm just going to go ahead and write it. Square root of 16 is 4. So this would be the ratio of our perimeters. And to find the scale factor, it's kind of like it's backwards, but the scale factor would then be 4. So each dimension is 4 times bigger in the newer, larger version than it was in the old version. Okay. Next question. This is very similar to the one we just did. Again, they're making a new production from a drawing they see in a museum. The larger is going to be 49 times bigger. The area is 49 times bigger in the new one than the smaller old one. Okay, so we can set up a ratio of areas. I know my handwriting is terrible. Ratio of areas, and we end up with 1 to 49. To go backwards again to find the ratio of perimeters, we just take the square root. 1, 49 square root of 49 is 7. It says find the similarity ratio and the ratio of perimeters. Well, the ratio of perimeters we found was 1 to 7. Similarity ratio is going to be the exact same thing. Similarity ratio is also going to be 1 to 7. And the last question, number 30. A clown is riding a unicycle. Oh, these clowns. It says with a wheel radius of 32 inches. A wheel is a circle. Radius 32. Beautiful circle. So what's the distance the clown traveled if the wheel turned 120 revolutions? Well, if the wheel turns around one time, go all the way around the wheel, we're looking for the circumference. Circumference is 2 pi r, or pi times diameter. Since we're given radius, let's go ahead and use this one. So we get 2 times pi times radius is 32. 2 times 32 is 64. We get 64 pi. This is for 1 revolution. But we don't want to find 1 revolution. We want to find 120 revolutions. We're going to take that number and multiply it by 120. We're doing this 120 times. So 64 times 120 gives us 7,680. We keep our pi. This is the distance the clown traveled if the wheel spun 120 revolutions. Now this number does look a little weird, so if we want to go ahead and put it in multiply out by pi, that's fine, we can, to find a more realistic number, something that we would understand, and that ends up being 24,127. Let's go ahead and round it to the tenths place, so 0.4. And this would be inches. So this clown traveled 24,127.4 inches. Okay, that's it for this worksheet, and good luck on your test.